6 is a Ferris wheel problem, and you have a person who is rotating around the Ferris wheel at 3.2 revolutions per minute. They give a location at time equals 16 of the northernmost point on the Ferris wheel. So we can translate that into being essentially 90 degrees of rotation. So it's going to be vertical right there. And then we're asked to find where is this person located, what is their x, y, or what is their height, which is just going to be the y coordinate, after 9 minutes. So our task is going to be to find the start theta, so the original, and then we're going to allow them to rotate for 9 minutes, and then we're going to see where they are, see if we can find some kind of theta of final rotation after 9 minutes. So let's see if we can do that. Alright, first of all, we know that the Ferris wheel is 14 feet off the ground. It has a radius of 45 feet. Therefore, it's 59 feet off the ground. So our x and y coordinates, we're going to have to add a value onto that once we find them. So the 59 feet is going to be our k value. If we are told that at time equals 16 seconds we're at 90 degrees, then we can use omega times t times 360 degrees and get our angle of rotation in that 16-second time interval. So let's plug in our angular velocity, which is 3.2, and that's revolutions per minute. So we got to turn it into seconds because our time is in seconds. And then if I take that whole calculation, I will get a fraction of the circle, which then I have to multiply by 360 to get an angle measure. If I do all that, I get 307 degrees. And I'm going to have some rounded numbers in here, so you'll have to just follow these calculations along and make sure you get exacts. So 307 degrees is going to be the rotation from backwards from 90 degrees. So if I go backwards from 90 degrees, I get to my t equals 0. So I got to go back 307 degrees, and that yellow portion right here is going to be my 307 degrees of rotation from the vertical point. So if I go back in time 307 degrees, I've gone back in time 16 seconds, and that's going to leave me a gap of a full rotation of essentially, so there's 360 degrees, but I only went 307, so that leaves a gap there of 53 degrees. The reason that's helpful is because now I can get this yellow portion of the circle, which is 90 plus 53, which is 143 degrees, which is my theta initial. Alright, so my theta initial is 143. So that's helpful. Now I'm going to let this person hop on the ride and go for a total time of rotation of 9 minutes. So 3.2 revolutions per minute times 9 minutes is 28.8 rotations. So since they've gone around 28 full times, I don't need that. All I need is the portion or the fraction of the circle past a full rotation. So if I take 0.8 times 360, I'm going to get an angle measure of 288 degrees, which is 288 degrees from time 0. So I've gone 360 degrees 28 times, and then I've gone an additional 288 degrees. So if my original was 143 degrees, and I go 200, there's 180 degrees, and I'm going to keep going, there's 270 degrees. Now I've gone 288 degrees from the original, then essentially I've gone around the circle 143 degrees and 288 degrees, which has an overlap of, or is a total rotation of 431 degrees, which then essentially has an overlap there, right? Because I've gone over 360 degrees. So I have an overlap of 71 degrees. So this yellow portion in here that I'm highlighting now in red is 71 degrees. So now that's enough to just simplify this whole picture down. So I have basically an XY coordinate where I have a theta of 71, I've got an origin at 59, I've got a radius of 45, and so now I can use, since I only want the height, which is a y coordinate, I only need r sine theta plus k. Well, the r is 45, the sine is 71 plus my 51, or 59, gives me 45 times 0.95 plus 59. The y coordinate is 42. I got to add 59 for the height, and I'm roughly at 102 feet. Now again, these are rounded numbers, so you'll have to do your calculation exactly. But the 43 feet or 42 and a half feet is my y coordinate. If I add the height of the origin, I end up with my 102 feet off the ground. So, simply put, we essentially found an original location, which was at time equals 0. We were at 143 degrees. Then I let the rotation spin for 9 minutes, which took me around 28.8 times, and that got me to right there. And then since 360 degrees and 288 and 143 is over 360, I really only need that portion right there, which is 71 degrees. And then that brought me back to this picture right here, where I had 71 degrees, r of 45, height of 59, and then I'm able to do this final calculation right there and get 102 feet. So there it is. There is problem 6.